1.
All right, so we're moving right along here. I think in this particular one, this problem, we're going to rename our function. All right, in this one here, let's go ahead and do x squared. And also, let's rename our function. We'll call it g. How's that? Doesn't have to always be called f. We'll call it g. Okay. And of course, we're looking for g prime of x. Now, if we do this, we must just go ahead and let's see, we're still doing delta x. We can change that too if we want. And we'll just call it small g. It doesn't matter. Capital G, small g, it doesn't matter. All right. Just going to show you that we can actually call these anything we want. Okay, so we want to find g prime of x, and we're going to use the definition of the derivative here. So what's the first thing we're going to be doing? All right, this should be our third problem now. We're going to be finding this guy here. Okay, so that's going to be the first thing that we want to do. And of course, it doesn't let me copy paste that. I'd like to try to use keyboard shortcuts if I can without touching the mouse. Okay, so we're going to have g of x plus delta x. I guess it's not going to let me do that. So let's, all right, is equal to. Now remember, whatever is in parentheses right here, okay, this x plus delta x is going to be going in right in here for this x. Okay, so you got to keep that in mind. Got to keep that in mind. All right, keep that in mind. I know it took me a little bit of time to wrap my mind around that when I was first learning this stuff. All right. So we're going to go ahead and put a parentheses. Okay, and squared. So we're going to need to multiply this thing out. We're going to need to multiply this thing out, as you can see here, this x plus delta x. But I think what I'm going to do is, I think, instead of skipping too many steps, we're going to go ahead and skip too many steps and you'll get confused. All right. So this x plus, or this piece right here, okay, what's going to go in there? Well, it's going to be this whole thing right here. Right. The whole piece right there, that's what's going in. And we'll multiply that out here in just a second. But I want to show you this so you see the big picture. Okay. All right, and of course we have x squared because that is our function. Okay, but what we're going to need to do is we're going to need to, this thing is squared, we're going to have to do some math here. We're going to have to do some algebra. That's what we're going to have to do. And we're going to go ahead and come right down here and do that. All right, so this is equal to what? We have two of them. It's x plus the delta x, right? X plus delta x. X plus delta x. Right? Right? See that? There's two of them. Okay. So this is that intermediate algebra stuff that we got to refresh your mind with. So we need to go ahead and multiply this thing out. Right? So you always multiply the first terms, x times x, which is equal to x squared. I guess we'll try to get this all on one line here. Is equal to x squared plus, hopefully, you know what, I don't think we're going to have enough room. So let's just go ahead and move it on down right there. All right, we'll just move it down to here. So x times x was x squared. And I don't know why. Oh, it went down to 18. Okay, we want to kind of keep it a little bit larger font is what we want to do here. Okay, it looks like it's going to stay. All right, so x times x is x squared, and then we have x times delta x, x times delta x. Copy that delta x. So that's going to be plus x times delta x plus, then you have delta x times x, delta x times x, delta x. I'm going to go ahead and just put a parentheses around that because that looks kind of funny, putting that x and then that other x next to it. And then plus the last term, which is delta x times delta x. So delta x times delta x. That doesn't look too bad there. Now we can go ahead and simplify this. And what we could actually write here is an equal sign. Okay, meaning that we're carrying this line down. Okay, carrying this line down. And I think because a lot of this we're going to repeat, I'm going to go ahead and just copy that and paste it. Okay, so we have some like terms in here. We have an x delta x and a delta xx. Those are the same things. All right, so let me just go ahead and that means there's two of them, right? There's two of them. Two x delta x's in there. Okay, and this guy here can actually be rewritten. We have delta x times delta x. It'd be like saying x times x is the same thing as x squared. It's the same thing as x squared. So what we could do here is, let's see, I don't know, let's do this. Okay, so this is really assumed to be 2x, or delta x. Squared means there's two of them. It would probably be more appropriate to maybe do this, saying that the whole thing in parentheses is squared. I think that's what we'll do there. Okay. All right, well, finally, we have this up here. Okay, so we had to multiply all that out. And remember, that's going to get placed. That's going to get placed right up here. Okay, that's going to get placed. So that's going to be the next thing we do. We're going to go ahead and rewrite that. So we had to do a little side work on that one. And that's what I'm saying. These things can get really nasty. Now, we're going to have shortcut methods for all this later on in the story. Right? That's what the rules of differentiation are all about. Shortcuts. Okay. So that's going to go in right up here in the numerator. Boom. All right. And of course, we don't need this equal sign. Now, minus g of x. Now, what was g of x? Well, g of x was just our x squared. Right? G of x was equal to x squared. Okay. So as you can see now, by looking at this, we're going to be able to cancel some stuff out. We have an x squared minus an x squared. You see that? An x squared minus an x squared. Okay, so let's go ahead and just, we're going to go ahead and we'll go ahead and just rewrite all that. Okay, and I'm going to say here that I want you to finish this. So these are going to get eliminated. We're going to be left with a 2x delta x and a delta x squared. We can cancel out a delta x and cancel out a delta x up here. And what's going to happen here is we're going to be left with 1 plus delta x. And then once we plug 0 into that delta x,